Okay, let's take a look at solving some exponential equations using logs. So in our first example here, we have 5 to the x equals 9. There is, of course, no way of rewriting 5 and 9 to have a common base. So this is where we must take the log of each side. Okay, so again, it's an exponential equation because our x is up there where the exponent is. So we're going to log each side. And so from there, recall that that power of x we can throw down in front. So you have x log 5 equals the log of 9. And then from there, we can get x alone by dividing over that log of 5. This is a nice, clean, exact answer. By the way, we can use our change of base formula to work backwards and rewrite this as log base 5 of 9. Okay, that's a nice exact answer. Perhaps a question may say to express it with a single log, so you'd have to use your change of base formula. Or if we were asked to round to 3 sig figs, we would have 1.37, and of course you'd have to enter it as log of 9 divided by the log of 5. So make sure that you are doing that in your calculator, making sure you get 1.37. Again, you're going to have to make sure that you close your parenthesis after the 9 when you're entering it. Okay? Okay, here's another example. Again, we're looking to solve, but this time we're looking to express it in the form log of A over log of B. So we're told that fact, so we're not going to express our final answer as a decimal. We must leave it in the form that they specify. Well, notice in this equation, again, we have a 6 and a 3 for our bases. There's no way to rewrite this with a common base. Please don't tell me that 6 is 3 squared. So notice, too, that we have more than one x here. All right, so we're going to need to take the log of each side. And we know that when we do that, the power is going to go down in front. So we have x times the log of 6. And by the way, we're going to use the common log because if we look at this form here, we can see that it's of the form log of A, log of B. So as opposed to, let's say, the natural log. So we want to use the common log. So we have x log of 6 equals, now I'm going to put that x plus 1 in parentheses as I drop it down and put it in front of the log of 3. If you don't put it in parentheses, it's only going to look like you're multiplying the 1 by the log of 3 and then just adding on x. Alright, so the whole thing there is multiplication. So what that means is we can distribute this log of 3 to each part. So we would have x times the log of 3 plus 1 times the log of 3. Alright, and we really don't need to put that 1 there in front. Well, notice we now have a couple terms with an x in it. So what you want to do is you want to bring your x terms over to one side. So I'm going to subtract over this x log 3 term, and then on the right hand side I would just have the log of 3 left. So we're looking to solve for x here, right? And so notice how we have more than one x in this expression on the left hand side. Well, we can go from seeing 2 x's to 1 x by factoring out an x as a GCF. So if I factor out an x, and again you can just mentally check this, if you were to distribute that x through, you'd have x log 6 minus x log 3. So from there we can divide this all over. So we'd have the log of 3 all divided by the log of 6 minus the log of 3. Well, again, go back to the form that they want us to leave it in. Okay, it looks like we have to have the log of something divided by the log of something. Well, that means we have to clean up our denominator. We have the log of 6 minus the log of 3. We know it's not going to be the log of 3. We need to turn this into the log of 6 divided by 3, which is the log of 2. So this would be my final answer expressed in that form. Okay, here's another example. We are looking to solve this equation. And if we look at our bases here, you can see one is e and one is 4. And if we look at our powers, you can see that we have more than one x in this problem. So because we see an e as a base, what we want to do is take not the common log, but the natural log of each side. So this power of 2x minus 1, I'm going to put that in parentheses, and we have the natural log of e. Again, that power gets thrown down in front of the log, and then we're going to have to take the natural log of this other side. Oops. Let me try that again. So you'd have that x down in front, and then the natural log of 4. So the natural log of e is just 1. Again, those are inverses of one another. So we're left with this 2x minus 1 is equal to x times the natural log of 4. So let's group our x terms on one side and our non-x terms on the other. Well, we have a 2x, and I can subtract over this, and if you want, we can write this as ln of 4 times x. ln of 4 is just some number, right? And then this minus 1, I'm going to add that over to the right-hand side, so I have a positive 1. Well, from there, I can take out, if I look at my 2x terms, I could take out a GCF of x. I'm left with 2 minus the natural log of 4 equals 1. And then from there, divide over, and we have 1 over 2 minus ln of 4 for our final answer. Okay, so there's our nice exact answer. Again, if we wanted to express this as a decimal, we would want to make sure we put this entire denominator in parentheses, okay, if we needed to express it to 3 sig figs. But for now, we'll just leave a nice exact answer. Okay, last example here. So in this example, I want to point out that you don't want to be quick to just take the log of each side. Notice how there's a 2 in front here. What we need to do first is divide over that 2 so that we have 4 to the x equals 6. Okay, so the idea here is if we're going to log each side, you need to have some base raised to a power before you can do that. If you were to go back up here and take the log of each side, well then, because we have a product here, you would have to do the log of 2 plus the log of 4 to the x, which is making it more complicated. So always look to divide over a number in front, alright, that's being multiplied, as your first step. And then from there we can take the log of each side. When we do that, that x falls down in front. We have x times the log of 4 equals the log of 6. And then from there, x would be the log of 6 divided by the log of 4, which, recall again our change of base formula. We can rewrite this as log base 4 of 6. Okay?